Okay, here we go with section 3.3 study guide. So we're activating prior knowledge still summarizing. Today we're going to talk about similar right triangles, and we just finished unit 2 about similar right triangles. So remember that these triangles have the same shape and size. And 3 pairs of corresponding angles are congruent. So remember that similar triangles have congruent angles, and that 3 pairs of corresponding sides are proportional. So they are not congruent, they are proportional. So looking down at these 2 similar triangles right here, you've got 2 images, one of a small red one and one of a big one. We know that angle A is congruent to angle D. We know that angle B is congruent to angle E. Do you see it over there? And that angle C is congruent to angle F. We also know that AB corresponds to DE. Those are the diagonals. And then the backside, AC, corresponds to DF. And finally, CB on the bottom corresponds to FE. Okay, let's go fill out these little charts here. Triangle similarity postulate. We know if 2 triangles have 2 pairs of congruent angles, then the triangles are similar. Right? 2 pairs of congruent angles, at least 2. But a right triangle fact that we know is that any 2 triangles have 1 pair of congruent angles. They're right angles. Okay, so if we have 2 right triangles, we know they have at least 1 angle in common. They're right angles. And so right triangle similarity postulate is if 2 triangles have 1 pair of congruent acute angles, then the right angles are similar. Sorry, right triangles are similar. Because they already have the right angle, if they have another one, another pair of acute angles, then we know we have at least those 2 that are in common. So fill in the blank below for this one. This is similar right triangle theorem. So if the altitude of a triangle is drawn from the vertex of the right angle of right triangle to its hypotenuse, then the 2 right triangles formed are similar to the given. So hang on, I need to actually draw this so you can visualize it. Picture that you have a right triangle. And picture that you are taking an altitude of the triangle drawn from the vertex, so from right here, to the hypotenuse, that these right triangles that are formed are similar to the original right triangle. Interesting fact. So if you draw an altitude from the right angle of the hypotenuse to the right triangle, then you get 3 similar right triangles. So what is the 3? What are the 3? It would be this big triangle is similar to this right triangle that was formed, and those are similar also to this right triangle that was formed. So those are the 3 that they're talking about. Use a diagram to complete the similarity statement below. So triangle ABC, sorry, it rolled onto this next page here. Hopefully we can still see both. Triangle ABC is similar to triangle ADB. So again, the big one, ABC, is similar to ADB and is similar to triangle BDC. Good job. So those 2 little ones that were formed on the middle are similar to the big outer one. Okay, let's go talk about writing proportions then. So we could say that AC is to BC as BC is to DC. And so plugging in the numbers from that image above, we're going to go 7 is to X. That's the long side compared to the bottom of that one. 7 is to X as X is to 3. So when I multiply through, X times X makes X squared. 7 times 3 makes 21. We get that X is equal to the square root of 21. or 4.58, and therefore BC is equal to the square root of 21, or 4.58. Okay, let's talk about this little miniature golf problem. What do I want to know? How far down the wall do you need to hit the ball in order to make a hole in one? So if the hole is 15 feet away and you bounce the ball off of the right wall to reach the hole, we're going to talk now about predicting using a diagram to see the problem. The walls of the course and the path of the ball make two right triangles. So again, we have to tie this in somehow to right triangles. I will prove that the two right triangles are similar, so then I can use proportions to solve. So let's go draw a diagram. Picture having a right triangle here, and then we've got the wall bounce. So we've got A and B, and down here, let's call this C, and then D and E. And here's my right triangle, here's my right triangle. And let's label this 6, let's label this X, let's label this 15 times X, and let's label this 3. Using the diagram to prove the right triangles are similar, we could say that angle ABC is congruent to DEC. So ABC is congruent to DEC because they are both right angles. Angle ACB is congruent to angle DCE. So let me get a different color here. Because of the AA postulate. Because they are the angles of incidence and reflection. And so then AA similarity postulate, or AA similarity theorem, is the reason we can say that the triangles are similar. So by using those two angles, this right angle and this reflected angle, which we now know are true, we have our two angles to prove similarity. Okay, now that we proved that they're similar, we can use the triangles to write and solve a proportion. So looking up, sorry, it's actually done in the table here. We're going to say 6 is to 15 minus X as 3 is to X. Now going back up here, right here, sorry, that's a minus. So then we cross multiply, and we're going to say 6 times X is equal to 3 times 15 minus X. We're going to distribute that to get the next row. We add the 3 X's to both sides. We divide by 9 and get 5. See if you can follow along and understand where that all came from. But basically, we're just showing you another opportunity with similar triangles, now that they're right triangles, to use a proportion to solve. Okay, so what's the answer to my question? We need to hit the ball 5 feet down the wall in order to make the hole in one. That's where it's going to bounce off the wall and hit right into the hole in one. Okay, now let's do some practice examples. Again, this is like what it would look like on your APEX quizzes and tests. And remember that this APEX quiz is optional if you want to go try it. Any points you get just help. We're being asked to set up a proportion here. And remember, there's lots of ways to set these up. So what if I first just look at this little triangle, and I'm comparing this using the side length of 12 on the back and the side length of H on the base. What if I compare that one to this guy using the tall height and using the base of 6? So I'm going to go ahead and set up a proportion as tall back is to base as tall back is to base. So I get 12 over H equals H over 6. When I cross multiply this, are you noticing that sometimes we can get quadratics? H squared is equal to 12 times 6 is 72. When I take the square root of both sides, I'm going to get plus or minus some simplified number. But because we're talking about distances and lengths, we're not going to use the negative answer. Only the positive answer is valid. If you do this in a calculator, you can round it to approximately 8.5. Or you can leave it as a simplified radical, take out a 36. It would be 6 root 2. Anyways, let's go try another one. Again, there's multiple ways to set this up, multiple ways to try it. But what if we look at this as the base and this as the height, and then we compare that one to this height and this base? We're kind of using the two little triangles to do it. So we could say 13 is to h as h is to 10. And again, when I cross multiply, I'll notice that this is a quadratic. So when I square root both sides, I'm going to get that h is equal to, and if you do that on a calculator, we could approximate and say 11.4. Remember that whenever we're doing a distance or a height or a length, we're going to put u for units if it doesn't tell us the units. Okay, let's go try 3 and 4. Same thing, using proportions to set this up. And again, if you pause this and try it on your own, you could use a totally different proportion than I use, and it still will work out to the same answer. So what if I do 14 is to x as x is to 34? Now this time, where the heck did I get a 34? Does everybody see that I can add 14 plus 20 gives me 34? So I can use the big side if I want. Cross multiply, I'm going to get x squared equals 14 times 34. Can't do that one in my head. Let's grab my phone calculator for a sec. And I'm getting 476. And if you take the square root of that, you're going to approximate to 21.8. Okay, going over to this next one, we could say 8 is to x as x is to 13. X squared equals 8 times 13. Again, another big one I want to just do on my phone calculator. That's giving me 104. And then when we square root both sides, we're going to get that x is approximately 10.2, u for units. How'd you do? Why don't you pause the movie and try 5 and 6 on your own, see how you do. Okay, let's check it out. Remember that if you set up a different proportion than me, it's still okay as long as you got the same answer. So we could say 13 is to h as h is to. Now this time I'm going to show you something tricky here. I'm going to do it to 9. Where the heck does this 9 come from? If I did 22 minus 13, do you guys see how this side length would be 9? And I'm going to get h squared when I cross multiply is equal to 13 times 9, or h squared is equal to 117. Square root both sides. H is approximately 10.8, u for units. How'd you do? Finally, we could go 4 is to h as h is to 5. There's so many ways to do this, you guys. You seriously can choose any way you want as long as you get the same answer. And so h is going to be approximately 4.5 u for units. How'd you do? Okay, last but not least are kind of like that golf ball problem, showing you this one. So what is the length of CD in the figure below? So down here, solving for x. So here I go setting up the proportion. I could say 24 is to 8. Where does that come from? Can you visualize these guys? As 25 minus 2x is to x. So I went left is to right as left is to right. Now I go cross multiply. I get 24x from the first diagonal and 8 times 25 minus 2x for the second diagonal. 8 times 25 is 200. We're going to add that 16x to both sides. I'm going to get 40x is equals 200. And we get x is equal to 5. U for units. How'd you do? Okay, looking at this other one, kind of like the golf ball problem. Pause the movie and see if you can set up the proportion and solve. Okay, let's see how you did. Did you go 10 is to 21 minus x as 7 is to x? Notice I went left is to top as left is to top. And there's so many other ways you could have done this. Let's see if you got the same answer as me. 7 times 21, 147. Does that work? Check me on that one. And then we're adding 7x to both sides. And we're dividing both sides by 17. I'm getting x is equal to 12.4. I'm sorry, x is equal to 8.6. Now, it didn't just ask me to solve for x. If you look back up here, it asked me for the length of BC. So it actually wants this answer. So I need to take x and plug it in. So the length of BC is equal to 21 minus x, and we just got that x was 8.6. So take a second to subtract this on your calculator. Good. I got 12.4 also. So be careful with what it's asking for. Did they want a length of a side that I had to plug back in for, or did they just ask me to solve for x? Last but not least, a little multiple choice here. Emma is playing miniature golf. Her ball is 2 feet to the left of the right-hand wall. The hole is 4 feet to the left of the wall. The distance along the wall between the ball and the hole is 18 feet. There is an obstacle between her ball and the hole, so Emma must hit the ball to the right to reflect it towards the hole. How far did she aim? So we're going to set up a proportion. I would love if you actually could draw out a diagram of this, where it's 2 feet to the left of the right wall, 4 feet from the left of the wall. The distance along the wall between her ball and the hole is 18 feet, and there is an obstacle between. So try to sketch a diagram whenever you're reading that and put that into your problem. So we're going to say 4 is to 18 minus x, and 2 is to x. And then we solve all the way. And if you need help in how to figure out how to fill in that diagram, actually this is in feet, they gave us the units this time. If you need help with how to fill in that diagram, you're not understanding what goes where, feel free to come to office hours or ask me in class one time after notes. All right, same thing for number 10. I hope you can draw a diagram, but we should get a proportion that solves something like 6 is to 9 as x is to 24. We cross multiply and get 9x equals 144. We divide and we get 16. So this one up here was 6, sorry, letter B, and this one right here is 16, letter C. Remember that the Apex quiz is optional. Do you feel like taking it? Go for it.